Okay, so joining us tonight, my name is Colleen Bailey. I'm the Director of Enrollment Management. We're also joined tonight by the Department of Bioengineering's Department Chair, Dr. Peter Lelkish, and by Dr. Leah Bellis, who's an Assistant Professor in the department.
Hello.
So without further ado, I'm going to turn it over to, well, first I'll discuss this real quick. I got lost up on my slides a little bit. So just a quick little snapshot about Temple Engineering. We were founded in 1969, so we're just finishing up our 50th year, which is very exciting. We have about 1,700 total students, so about 1,500 undergraduates total and about 200 graduate students. And that's important because by comparison to some of the other colleges and schools at Temple, we're pretty small. So by comparison to like the business school or the College of Public Health, we're one of the smaller colleges within a big university. And what that means for you is that you really get the best of both worlds. So you have the small college environment with all of the benefits and access and collaboration opportunities that a big urban research university affords you. The College of Engineering is about 25% female, which is above the national average, which I believe is about 21 to 22%. And we are 37% non-white, so we have a very diverse student body, and we have about 130 international students that are currently with us in the undergraduate program. Now, the Department of Bioengineering, to give you a sense, is about 275 total students. So we have 240 undergraduates and 35 graduate students, either in the MS or the PhD program. And you can see there's a nice balance gender-wise. So it's 55% female and 50% students identify as non-white. So again, a very diverse department, which we're very excited about. So now to talk a little bit more about the major, I'm going to turn it over to Dr. Lelkish and Dr. Bellis.
Okay, so let me get started, but I wanted to have one more look at the previous slide, or I can say it here. First of all, good afternoon. Thank you for participating. And the other comment I wanted to make, while the college celebrates its 50th anniversary this year, we, as in the Department of Bioengineering, are much, much younger. We are barely 9 years old. I came in as a founding director and then founding chair, and we really have gone from 0 to 275 in a few years, and now we have a steady state. And importantly, our program is ABET accredited. After the minimum amount of years, it was ABET accredited. Now, so let's go to the next slide, please, and talk about what is biomedical engineering. So my first question would be, what does the word bioengineering entail? What is the difference between bioengineering and biomedical engineering? So if you look at the words, bioengineering, the word is, you know what engineering it is. I don't know whether you all know what the word bio comes from. It's a Greek word for bios, which means life. So in principle, bioengineering is engineering life. And if you, this is the broader concept. And if you narrow it down to applications in the medical field, this is biomedical engineering. So biomedical engineering, if you want, is a subtopic of bioengineering. And biomedical engineering is essentially a highly interactive, it's a highly interdisciplinary science and engineering topic, which includes biosciences and then engineering, intersecting, and then also incorporating medicine. So bioengineering, engineering life, and finding engineering solutions to biomedical problems. Next slide, please. So as I showed you before, it's the intersection between engineering, life science, and medicine. And the focus of our research and of our activities is to improve, not yet, can we go back, is to improve human health and human well-being by developing, first of all, fundamental theories, systems, and products, but then also a translational application by developing devices for medical treatments, dialysis, prosthesis, MRI. Some of the major inventions in medicine come from the bioengineering field. Then there are instruments that we develop for monitoring biological processes and as we are studying life. So bioreactors, and Dr. Bellas will talk about her kind of bioreactors. I'm using a different kind of bioreactor to study, for example, assembly of organs and organoids. We can make artificial and bioartificial organs, such as if you need a spare heart, if you need a replacement of a heart, of a lung, etc. And then we also work together with some of the agencies on developing, fabricating life support systems for underwater and space explorations. Spacesuits, for example, are developed mainly with the input of biomedical or bioengineers. Next slide, please. So let me give you some examples of, Colleen, if you would kindly go with your cursor to the top left panel. This is an old-fashioned prosthesis. It's built after the hand, and it's actually, it was developed, such a fine motoric was developed in the 16th century, and it took about 500 years or 400 years to bring it up to snuff today. And you see under it a functional prosthesis, which can give you, with electronic and mechanic guidance, it can give you the touch to hold a raw egg or to write with a pencil. In the middle, on the top of the middle, we have one of the highlights of biomedical engineering development, an artificial heart. Underneath, we have some biomedical imaging, in this case an MRI, depicting a tumor in the middle of the brain. On the right side, on the top, we have a system in which we can check the mechanical properties of individual cells. You see this brown blob in the middle is a cell that is hugging some posts, and the posts have mechanical properties. And as much as you bend the post, or as the cell bends the post, you can calculate the mechanical forces. And down on the bottom, we have several things which, several images which show a microfluidics device, and Dr. Bellas will talk about this. And then you take such microfluidic devices, and then on the top left in this panel, you see something which is a tissue on a chip. For example, you could make a lung on a chip, or Dr. Bellas makes adipose fat tissues on a chip. Next slide, please. So you come here to study bioengineering. So what can you do, and where does a bioengineering, a bachelor's degree lead you? You can find employment in a pharmaceutical company as a reliability engineer, for research and development as a test engineer. You can work similarly in medical device companies. Quite a few of our students have gone on to consulting agencies, to patent offices, to look also for equipment sales, equipment repairs. Our students have gone on to work in university labs as technicians, managers, or in research. You can go to military, you can conduct orthopedic surgeons, research, you can work with orthopedic surgeons, you can service medical devices, etc., etc. So you have the capability, you have acquired skill sets to work in a number of diverse careers. Next slide, please. Also, quite a few of our students don't stop just with the BS. They go on to secondary education, higher education. So many of them go to medical schools, become physicians, or do medical research. And it's quite common to have a bioengineering background to go on to medical school. And actually our program is a pre-med program, a pre-health program. So people coming into our program with the intent to going on to medical school. You can go on to graduate school to get a PhD, a master's and a PhD. With this, you can do research at universities and industry and government labs. You can be an engineer consultant. You can become an entrepreneur. And actually some of our students have done exactly that. Or you can teach at the university or higher levels. Or you can also go to law school and work on intellectual property and patent laws, which we also have in some of our graduates. Next slide, please. So I think here I would like to hand it over to Dr. Bellas, if it's okay with you.
All right. Hi, everyone. Thank you for the nice intro to bioengineering. So Dr. Lelkish is right. It's a really interdisciplinary field that really brings together the idea of engineering life. And so what I'm going to talk about is a little bit more on what our department is really like and how we try to approach bioengineering in our specific department, because every department has a little bit of a different flavor to their bioengineering. So our way of approaching bioengineering is really to look at it from a translational side. So we look at translational engineering research. This is something that we commonly hear as bench to bedside, which means it's in the laboratory bench. We start there, and our idea is to get all the way into clinical practice. And then we also do a lot of applied research. So that's the big chunk of the rest of our department's research, is to generate fundamental knowledge, the ability to seek engineering solutions to medical problems. It's not have technology look for a problem to be solved. Instead, we approach it as we see that there's a problem or an unmet need, and then we try to solve that problem using our bioengineering techniques. And so our students have been really amazing, especially at the undergrad level. They are the ones that are solving today's real world problems. I'm a little bit competitive, and so I enjoy senior design competitions. Our bioengineering teams tend to do the best, and sorry, Colleen, you know, when you have to talk about the other departments in the College of Engineering, they can't brag like we can, right? Our teams tend to do the best because we really approach problem solving, you know, in a way that really identifies these needs that people need filled. So our teams tend to do the best. Both Dr. Lelkish and I had winning teams in the last year, and we're both very proud of our teams. And they also go on to present their research nationally, whether that's part of this senior design work or if it's part of the undergrad research that they do themselves. Like Dr. Lelkish mentioned, we have some entrepreneurially active undergrads. I can speak at least from one of my classes. A student took what he had learned in our tissue engineering capstone class, and he spun it out into a company that raised money within the same semester he was taking the class. So it's amazing, and Temple has a lot of great opportunities to build your potential business. So it's something else that might get some of you excited beyond just the academic commitment that an undergrad curriculum entails. We also do a lot of outreach in our department, and a lot of summer research, academic year research. There's REU's research opportunities or experiences for undergrads that a lot of our undergrads participate in. And we have a summer program within our department as well that's dedicated to undergraduate research. Next slide, please. Here are some examples of what undergrad research looks like in our department. So you can see it's not just at the bench. These are a lot of moments where we get to celebrate some of our wins and our hard work. So you can see in the top left, one of the labs took their group rock climbing to burn off some energy. The next picture over to the right, Colleen, do you mind using your cursor? I keep using mine and I forget that I'm not controlling the screen. The middle one, yep, that's our first senior design team, my first senior design team that went on to win. They miniaturized an organ on chip so that they can use it for high throughput applications. The next person pictured, she had developed a cream that helped people that scratch their skin too much from anxiety problems. And her product went on to be sold on Amazon and got picked up by a bunch of other outlets as well. And so that was really exciting to watch an undergrad, you know, just really hone her skills in that sort of business mindset. On the right there, you can see Nico and Jen presenting their research posters at conferences. On the bottom right, this is what we have as Engineering Week. We have demos that our groups do. So what you see down here is our Biomedical Engineering Society chapter. They are putting on a demo using, I think, some version of prosthetics and muscle actuation. So it was really exciting. They used 3D printing to develop some of these models. And then on the bottom left, it's a winning team after their senior design competition. And then the picture sort of in the middle on the left, that's from our clinical immersion program that's dedicated to undergrad research. So we have a program that is NIH funded, and that is to take students and bring them to the hospital at Temple and really to see what, you know, the clinicians deal with every day and to really understand the clinical unmet needs so they can develop the technologies to help. Next slide, please. All right, so our bioengineering mission is interdisciplinary in focus, and we focus on excellence in research and education, so we have strong focuses in both. We are a living bridge between the main campus and the health sciences campus. And the health sciences campus is much more than just medicine and dentistry. Those are two of the bigger schools, but there's also public health. There's, oh my goodness, I can't remember all of them, but there's
Cancer Institute, Fels.
Yep. There's
pharmacy,
right? There's a bunch of other schools there. It just happens that medicine and dentistry tend to be the biggest ones and the ones that most of us end up collaborating with. I think both Dr. Lelkish and I are jointly appointed to departments at the med school as well. So we definitely have this sort of living bridge between the two campuses. And so we have, like I mentioned, joint faculty, joint students, joint grants, and a joint institute. So that really helps the crosstalk between the two campuses, even though they're just a couple miles away from one another, just up and down Broad Street. And like you've probably gotten the impression, we are innovative, inspirational, translational, and entrepreneurial in our mission. Next slide, please. So as a quick overview, sort of in our personal timeline, we started in 2012 with just 3 core faculty that were focused in biomaterials and tissue engineering. And as Dr. Lelkish mentioned, we rapidly expanded from that, and we established officially the BS program in 2013. And now we have 3 established pathways within that curriculum. So we have an engineering devices curriculum, we have a cellular engineering, and we have a pre-health. So you tend to go into one of those 3. I think you start that officially in your sophomore year. You don't have to sort of commit in your first year. But then once you end up in one of those 3 pathways, then you take specific classes that help you sort of harness your skills and your academic knowledge in devices, cells, or pre-health. And we have also a combined degree in a BS-MS degree that was approved in 2014, and a good chunk of our students go on to do that. So they take an extra year after their undergrad to complete a master's in bioengineering. Currently, we are at 14 faculty, so we have 9 tenured or tenure track faculty, 5 non-tenure track, and that's both in research and education. We have 3 full professors, 3 associate professors, 8 assistant professors, and we are 47% female in our department, which for an engineering department is a big accomplishment. So we mirror our student body in that we are about 50-50 male-female. And our student numbers, as mentioned, were about 300 undergrads and about 45 to 50 graduate students, and they're split between master students and PhD students. Next slide, please. So here you can see our beautiful faces. We did dress up for this day. And so you can see that when the faculty have the red box for their name, those are the research active faculty. So they're in the top row and about halfway across the second row. The people in sort of the mustard yellow named boxes, those are more education focused. And then you can see our 2 wonderful staff that help us with our day-to-day and getting us through everything that we need. And yeah, next slide, please. And here you can see how we break down some of our research focuses or foci. So on the left, going top to bottom, you see our technical areas of expertise. So they're broken down between cell and tissue engineering, and then there's sort of hybrid cell tissue engineering, and then silicone, which is more of the device-based that you saw in the curricular pathways before. So within those technical areas, they break down into subspecialties, and you can see a whole list of them there. I'm not going to read them all off, but you can see how they range from more cellular-based approaches to biomaterials to imaging focused. And then in terms of our therapeutic and diagnostic focus, we span things from cancer to angiogenesis to metabolism, neuroengineering and neuromechanics, space biology, musculoskeletal engineering, extracellular matrix engineering, and low resource healthcare. So you can see how our faculty kind of span a bunch of different focuses and or technical areas and focuses in their research. So our undergrads end up joining all of these labs that we have and they do undergrad research. So you have quite a selection of areas based on your interest. Next slide, please. And to reflect sort of our diverse and interdisciplinary areas of research, we are funded by various federal agencies, including the NIH, so the National Institutes of Health, which you might be hearing a lot about in the news lately. So Dr. Fauci, who's on the news quite often, he is a director, one of the directors under the NIH, and we're also funded by the NSF and NASA, the Shriners Hospital, the Craig H. Nielsen Foundation, the Gates Foundation, VentureWell and Lemelson, and the Army. So we're quite diverse in where we get our funding from for research and for education. Next slide, please. Thank you. So as Dr. Lakish mentioned, we have various BioE programs, and our bachelor's in engineering and bioengineering is ABET accredited. So we passed with flying colors, which is really nice to hear because we work really hard to give you the best education that we can. And then we also have a master's in bioengineering and a 4+1. So that's where the bachelor's is completed in about 3.5 years, and the last 1.5 years is focused on trying to work through getting your master's. So it's a 4+1 program, even though the numbers are a little misleading there. But you end up with a master's and a bachelor's in 5 years. And about 40% of our seniors are enrolled in that. So it's a pretty big program for us. And then we also have a PhD in bioengineering available too. And something of note is that we are a Research 1 category university, which is the highest rank for research activity, which is a big plus as well for us. Next slide, please. So we have a lot of programs that are ongoing that are outside of just the standard academic curriculum. We have weekly seminar series where we invite researchers to talk about their work. So these are some of the top researchers in the world that will come and give a talk on their research. We have professional development seminars. And we also include student presentations within that weekly seminar series. And if you're ever interested in, poking in on one of those seminars, they're on Zoom now, so it's pretty easy. Maybe you can let Colleen know if you're interested in joining us. We can send her the link to send to you so you can see what those look like. And we also have strategic alliances and collaboration. So this is opportunities for joint research projects or mentoring across campuses, even across universities sometimes. And you can see how this breaks down. So it's either across main campus, where we collaborate with others in biology or computer sciences or business. Like I mentioned before, health sciences campus, we work pretty closely with them. And a lot of our collaborations, while they can maintain themselves sort of regionally, we also have collaborations nationally and internationally as well. So we're all over the place in a good way. Next slide, please. So yeah, we also like to promote what we do on Twitter. and Instagram. So we had a little bit of a slowdown because of the COVID pandemic with our social media, but it's back up and running, and you can see what we're up to on Facebook, Instagram, and Twitter. Although Facebook's been a little quieter lately, we find that Twitter and Instagram are better ways to connect with people. So please follow us or check us out on at Temple BioE. And I think that's it for me.
Yep. So everyone, here is all of our contact information. So myself, Dr. Lelkish, Dr. Bellis, and any general questions that you have, you can email to the address that you see there. At this point, though, we're going to turn it over to some of our current students who are going to talk to you a little bit about why they chose bioengineering, what they do in the department, and then once they're finished, you'll have the opportunity to ask questions of them. So I'm actually going to turn it over to Hannah first. So Hannah, if you want to unmute yourself and take it away.
Hi, my name is Hannah Sabatka-Briner. I am a senior bioengineering student at Temple University. I have a biomechanics concentration, so that means my track is a little bit more forces and loads, but I also work in Dr. Spence's lab, which is both a biomechanics and neuroscience lab, so I've been with him for the last 3 years. I'm also vice president of our co-ed professional engineering fraternity, and I'm on the events committee for the Society of Women Engineers. So I'm pretty well involved in the College of Engineering and in bioengineering specifically. So I chose bioengineering because I have always loved sharks, and that led me to be fascinated with prosthetics. And I thought that prosthetics should be like way better than like what they are. There's this guy that came on Shark Week that had a different prosthetic for like every activity that he had to do, and that just seemed kind of dramatic. But obviously once I got into the bioengineering curriculum, I was like, wow, this making this thing is a lot harder than I originally anticipated. There's actually a class that you take as a freshman coming into the bioengineering department called Frontiers to Bioengineering, and all of the different heads of bioengineering get to come and talk about their research or their experiences. So it really exposes you to like how huge bioengineering is, and that kind of got me interested in biodevices and just kind of different things in bioengineering. So I know we talked about it like before, but it's a huge field and it's amazing. So yeah.
Great, thanks, Hannah. And Hannah, as a senior, I don't want to put you on the spot, but what do you think your plans might be after graduation?
So I'm enrolled in the 4+1 program right now. I haven't decided how I'm going to pursue my master's. I know that Dr. Spence would be more than happy to allow me to do a research-based master's. We also talked with our advisor about pursuing our senior design project as like a project-based master's, especially since that's like, I'm working on a device to help limit lower back pain caused by lumbar lordosis onset by pregnancy in women. So that's obviously pretty well aligned with what I want to do. I also was talking to Globus Medical at the career fair, what was that, last week? And the recruiter reached out to me and asked me like to stay in contact with them because they are opening a new site and they're looking for new engineers. So who's to say, but definitely more education and work eventually.
Great, thanks, Hannah. Next up, I'm going to turn it over to one of our other students, Pram. You're going to unmute yourself and take it away.
Hi everyone, my name is Pram. I'm a sophomore bioengineering student here at Temple. My concentration is actually pre-health, so I'm on a little bit of a different track than Hannah. What that means for pre-health is that I'm taking more chemistry classes, more biology classes. I'm focused more on the medical side of bioengineering. One of the things that drew me to Temple over my other schools when I was making that choice was the fact that Temple has an established pre-health track for bioengineers. At a lot of other schools, they kind of leave it to you. So you're doing all of the engineering, all of the physics, all of the math, and you have to find a way to fit in all the pre-health requirements. On top of that, at Temple, you're given an engineering advisor and a pre-health advisor. So they're able to walk you through what you need to get done. And also all the professors are pretty understanding of the fact that you have both requirements to fill, and Temple makes it really easy to fit both into your schedule. At Temple and within Temple Engineering, I'm actually a pledge for Theta Tau, the professional engineering frat. I'm also a member of Tempo, which is the Prosthetics and Orthotics Club at Temple, and I'm also a member of BMES, which is our professional biomedical engineering society. Like Hannah was saying, between the Frontiers class and the 2 introduction engineering classes that you take in your freshman year, you're exposed to almost the entire engineering department at Temple, so you get a good idea of what to expect moving forward and all the opportunities that are available to you.
Great, thanks, Pram. Can I ask just one quick question for you on my end? What made you decide to major in bioengineering as opposed to biology or another life science program, given that you're interested in medicine and pre-health?
So I was exposed to science and its overlap with medicine pretty early on, and I was always kind of drawn to stem cells and all the different possible applications that could come with that. So I knew that I wanted to, in the end, do some kind of research on stem cells and stem cell applications. And for myself, the easiest route was to do bioengineering and then go to med school after that.
Great, thank you. And then finally, last but certainly not least, is Rebecca. So Rebecca, you can go ahead and unmute yourself and tell us a little bit more about you.
Hi guys, my name's Rebecca. I am a junior biomedical engineering major with a concentration in devices. So everything mostly external from the body, not stem cells or anything like that. But even though you do pick your concentration, you are exposed to the whole gamut of classes, courses, so that even if you do realize, I went in not knowing, I showed up to orientation and was like, I don't know what I want to do, but I want to be an engineer, help me. And they pretty much threw me into courses, told me, try and fail, because you're going to figure out what you really love. And so by the time I'm now a junior, I've gotten to learn what I truly like, instead of them just pushing me along, trying to get my money and keep me on course, which I feel is something that Temple does really well with. Especially, I know the other students mentioned the intro class, which you go through different circuits and you do every discipline of engineering, and you get to really feel what feels right for you. And so I'm highly involved in the Temple Engineering professional business circuit. I do all of the professional stuff with SWE, the Society of Women Engineers, BMES, the Biomedical Engineering Society, all of those. And they really help you make friends in your discipline. And so I highly encourage that if you come in as a freshman to just go to those events, because you really get to meet other students your age with your same goals, and you can help each other navigate through the college experience.
Great, thanks, Rebecca. And Rebecca brings up a good point, and I want to echo that, is to absolutely get involved if you come to Temple or wherever you go, because what I found in my experience working in higher education is that the best students are the ones who get involved and keep themselves busy outside of the classroom, because you know, it's very important. Your studies are very important, but it's also important to, you know, step outside and meet people in other majors and meet people within other disciplines in engineering as well. And Pram also brought up a great student organization that was started by a bioengineering student, Tempo, which is Temple Prosthetics and Orthotics. If you go to our YouTube channel, if you just do a search on YouTube for Temple College of Engineering, Temple's YouTube site will come up, and there's some really great videos on there about Tempo and what they do, and just about Temple engineering in general. And unfortunately, while we can't have you on campus just yet, that's a really great way to connect with us and get to know a little bit more about the college and about what we do. So now that you've heard from Dr. Lelkish, Dr. Bellis, and our wonderful students, if you have any questions for us, you can send those along in the chat. So if you hover your mouse either at the top or the bottom of the screen, depending upon where your Zoom controls are listed, you can type those in the chat, and we'll do our best to get to all your questions. Looks like we have one that came in. So this is from Simon. So being a senior then in high school and having to choose a university to attend, were you hesitant at first choosing Temple, or did you know that they had exactly what you were looking for? So I guess that answer is going to be different for each one of our students. So, you know, Hannah, do you mind taking that first? Kind of, you know, why you chose Temple and what was it about Temple that made you decide to come here?
Yeah, of course. It's kind of a funny story. I was at a doctor's appointment and my doctor told me to go check out Temple, and so I did, and I actually really liked it. What made me choose Temple over any place else that I had visited was just the people there. They were so welcoming, and especially within the College of Engineering, there's like such a sense of like familiarity, and it's just like a very comfortable place to be. Like in any one of our communal spaces, you can walk up to anyone and just be like, hey, can you help me with this calculus problem? Hey, like, do you understand what's going on in physics? So being able to just approach people in that way was very attractive to me, just because engineering is hard, and making as many friends that can help you as possible is honestly going to make your experience worlds better. So that's what did it for me.
Great, thanks, Hannah. Rebecca, do you mind going next?
Yeah, no problem. I was honestly stuck between choosing between Temple or Pitt University. And my main thing is when I walked on Temple's campus, before even viewing the campus or going on it, I did check out the accreditation of the engineering program, looked into the research, figured out if I was like a fit on paper. But then walking on campus, you get a feeling of, are you comfortable in this environment? Do you feel like this is somewhere you could live? You can spend your life for 4 years or more. And I really felt just walking on the campus, walking through the buildings, it was exactly what I needed. And I felt that instant fit for me because I knew I wanted to be in a city, but Temple is in a really good spot for me, that they're close to Center City, close to all the stuff, but I still feel like I'm a part of a college campus. And so that was really important for me, getting that college experience, not just being, okay, I'm living in a city and I'm taking classes, but I don't have that feeling. So I went more on feeling after knowing all the facts, and I feel like that was really important for me. And then getting highly involved when I got here was really what finished the whole process for me, because I find that if you don't get involved, you can really feel separated. And so when I got involved, I got really accepted and got a good group of friends in engineering that really helps finish off that transition for me.
Great, thanks, Rebecca. And last but not least, Prem, if you could give your version of the story.
Yeah, so I said this earlier, but for me, when I was picking my final school my senior year, it was between Temple and Penn State. And I went to Penn State first, and I don't know if you guys have been there, but it's huge. I thought I was gonna get lost. I thought like I would get there and I wouldn't know anyone. It's gonna be super hard to fit in and to find my place in this College of Engineering. And then when I ended up picking Temple without even visiting. And then when I did come and finally visit Temple, I knew right when I stepped foot on campus that I made the right choice, because it's a big enough school that you're not going to know everyone. You're going to be able to like have your own space, but the College of Engineering is small enough that you're going to get there and you'll see professors that you know, you'll see students that you know, you'll see people from your classes, from your clubs, and you'll make connections right away. And that was honestly more valuable than anything else.
Great, thanks, Prem. And looks like sort of a related question that Simon asked. Coming in as a freshman, did you have any second assumptions about choosing bioengineering? So I guess like the question would be, and Simon, correct me if I'm wrong, is, are you happy you chose the major and so on? So, Rebecca, I'm going to switch up order a little bit here. Rebecca, can you take that one first?
Yeah, honestly, when I was looking into schools, I didn't know I wanted to be in engineering at all. I knew that I enjoyed medicine, but didn't really want to go and spend however many years in medical school and residencies. I really wanted to get hands-on as soon as possible. And so I didn't even know I wanted to be in the major. I just picked one of the two and jumped in with both feet. But the one thing that the engineering college does a really good job of, and I know I've mentioned it before, is that first semester course. You go in and they expose you to everything there is no failure, because you're not going to be set back at all, because you're all taking the same course as your first year. And so you really get that exposure. And I feel like that's what's going to make you feel comfortable in your major or allow you to switch. I know a lot of students after taking that course or even during the course switch their major right away, because once you do it, you'll know if it's right for you or if it's not. Oh, but I have no regrets about choosing my major at all. I love it. I'm very happy with it. So yeah.
Great, sounds good. Prem, do you want to go next on that?
Yeah, sure. Like she said, your first year and a half or so, you're pretty much all taking the same classes within the College of Engineering. So there's a lot of overlap, and you're still able to switch if you decide that you don't want to do bioengineering anymore. For myself, I was always kind of set on bioengineering, and then when I got here, I was even more set. You're definitely exposed to a lot of different opportunities within the college and even outside of the college. So you're able to decide both within the classroom and without the classroom if it's the right thing for you. I think the most important thing is to go out and like find those experiences so you're able to decide for yourself.
Great, thanks, Prem. And Hannah, did you want to add anything to that?
I think it's honestly a lot with at least what Rachel said. For me, I had no idea what engineering was when I was a freshman. My one teacher in high school showed me a video of, I don't know if you guys know Boston Instruments Big Dog, but it's pretty much a machine that's able to like self-correct based off its center of balance. It's super cool. And he was like, yeah, the people that build this are bioengineers. And I was like, I'll do that. That sounds cool. And then I did more research into it and was like, prosthetics? And then here I am now. But yeah, I think the world of engineering is so much bigger than you can imagine. So even in bioengineering, like it's huge. So there's just so much to do that like even if you start with at like one end of the bioengineering spectrum, you can end up at the other end in like 10 years. You know, your abilities are limitless, especially with an engineering degree. So that's my hot take.
Great, thanks, Hannah. And Hannah brings up an important point. Dr. Brookstein, who's our Senior Associate Dean for Undergraduate Studies, always says to students in open houses, 10, 15 years after you graduate, you'll probably be doing something completely different than what you studied as an undergraduate in engineering. So it's very important to be flexible and keep yourself open to those opportunities. The next question is from Tyler, who, Tyler, I'm not sure if I met you, but I visited Northampton Community College in the fall, and your name looks familiar, but in terms of transferring to Temple for the bioengineering program, we do have a fair number of transfer students each year. I'm not sure how many exactly are for bioengineering, but if you want to, you can see my email address on the screen there. If you want to email me directly, for transfer students, it's really best if we just kind of work one-on-one and take a look at your transcripts and see kind of what's going to transfer and what your plan of study is going to look like. But in terms of what specifically to know, just pay attention to our deadlines depending upon whether you're going to be applying for the spring or for fall. The application is live for both of those terms right now. But if you want to reach out to me directly, I'd be happy to take a look at your transcripts and give you a better sense of kind of what your plan of study will look like. And I was actually just in touch with one of your professors today about talking to you guys again this semester. So hopefully we can connect over Zoom there at Northampton again. So.
Can I add something to that, Colleen? So I've had a few transfer students in my classes, and they've done really well, and I think they came in really nicely prepared. So I definitely have not seen it as an issue at all. I think the only concern that comes up with transfer students is that plan of study, and I think just if you work on that early with your advisors or with the people in Colleen's office, I think that's the most critical thing to work through, just to ensure that it's smooth sailing once you arrive.
Great,
Very
thanks,
good.
Dr. Bells.
Very
Go
good point, Dr. Bellas.
Thank you.
So Prem, this question is for you. For the PreHealth Focus, do you think it's preparing you well for medical school?
100%. I think because you're not focusing on the other two concentrations, you're set on the pre-health track. There's a lot of freed space in your schedule to fit in all of the other medical classes. Personally, with the way my schedule worked out with transfer credits and the classes I took freshman year, there's a lot of space for me to add extra classes that would fill medical school requirements, but are just optional for med students. So it's like stuff that would help for the MCAT, stuff that would help once you get to med school. So there's, even though you're taking a full engineering curriculum and you're taking all those pre-med classes, there's still a lot of space to work around what you want to do and what you want to focus on.
Great, thanks, Pram. And we have students that, as Dr. Bellis mentioned in the slides, go on to other health professions programs, like possibly PA school. I know of a graduate last year who went to pharmacy school, so the track prepares you for other health professions careers as well. This next question from Leah is, this is probably a good question for Dr. Bellis and Dr. Lelkish. How are the career opportunities for BioE graduates right now? And how would you predict them for future years? Would studying a more general subject like electrical engineering and then doing an MS in BioE introduce you to more opportunities in the US, specifically as a bioengineer?
Do you want to take a stab at it?
Yeah, I'll take this. Right now, the biotech industry that needs bioengineers is really in an upswing. So there's lots of demands. We all are aware of the COVID situation right now, and one of the approaches is to develop novel tests and novel, not only vaccines but novel testing methodologies which have innovative bioengineering approaches. It's not just the established antibody test, but now based on nanoparticles and based on lateral flow assays. All these things are being developed by bioengineers just in this particular area. Devices is very hot right now. Tissue engineering has become a hot topic because pharmaceutical companies are using tissue engineered models. The organs and tissues on a chip are very hot, and bioengineers are being taken in from on the after graduation already as an undergrads. So, Dr. Bellis, you have anything else?
No, I agree. I think our field is extremely hot right now in terms of where graduates have opportunities, because again, we are very versatile, and we can apply our knowledge to a lot of different problems. So you know, it's kind of true that you can start in one place and end up in a completely different place for your type of research or your area of interest within the bioengineering umbrella. And so, you know, it's really limitless. I think it's, you know, how you market yourself. I think, you know, your skills are what is important, not necessarily just the type of work that you do, but your skill sets and knowing how to apply them to different problems. So bioengineers are very much in demand, especially, you know, because of the pandemic, which is an unfortunate reason to be in demand, but, you know, the world needs us, and I think we can rise to the occasion for sure.
Just let me add that this area here is trying to develop its own characteristics of the biotech valley. So it's not just the Silicon Valley, but the biotech. And you have numerous biotech companies that have taken our students. So devices and such as Johnson & Johnson, just as so a number of smaller and larger companies have settled in this area and taking in our students. And our students actually can use these connections also to go for internships. We don't offer routinely co-ops, but we offer internships, which is a shorter period of time. And you can go to these companies, and if you do well in their internships, there's a good reason to assume that you will land a job with this company. And our external board advisory committee, always these are members from the industry, and they always stress how important it is to land a job. So you will have to have this internship experience, and we encourage all the students to go at least to one internship. And if they're doing well in this one internship, they will be invited to come back, go for a second or third internship over the years.
Great, thanks, Dr. Lelkish. Looks like one more question is, what is the experience like in any of the bioengineering clubs? That's going to be obviously a question for our students. Rebecca, do you want to take the first stab at this?
Or walking into a bioengineering club is really interesting because you know a basic set of things about everybody there. You all have a common interest, so it's really easy to make friends from the get-go. Based on curriculum-wise in the clubs, I know for the Society of Women Engineers, men are welcome. I just want to stress that even in the Women's Society, they are still welcome. It's just that society specifically works on bringing in female engineers from the faculty or the community that Temple's around with or in the field, and brings them in and tells their stories, gives us an insight into how they got where they are and have the success they have. And I know a lot of the other clubs do that as well. There's a mechanical and electrical, all of those stuff. Their main focus is to help you succeed in your job and to help you succeed in college with a good, solid friend group.
Okay, thanks, Rebecca. Prem or Hannah, did you want to add anything to that?
I can go.
Sorry, I was like, I think there's not a lot of clubs in the College of Engineering. I know like Tempo is a prosthetics club, but we have students come from like the business school and like we have biology majors that are on the e-board. Like I'm actually really good friends with the vice president and president, and I helped found the club. And it's wonderful that it's so inclusive that there isn't really any bioengineering specific clubs. Like even BMES has mechanical or electrical engineers who are just like interested in learning about what's going on. So like Rachel mentioned, there's a few more female bioengineering students than other majors. So SWE is a little bit more bioengineering heavy. So it's nice to like see more people that you might see in your classes. But again, like all of our clubs, even if they are bio-focused, are super, super diverse, and not even just in the College of Engineering. So that's a cool thing.
There is
and Prem, did you want to add anything to that?
I mean, Hannah covered most of it, but with what she was saying, there's a lot of diversity in every club that you go to. So you're going to get exposed to a lot of different skill sets and a lot of different disciplines. So even within like Tempo, because it's a prosthetics club, it's a bioengineering field, but there's people who work on that who are from all parts of the College of Engineering, kids from CST, so all your like biochemistry, and even like comp sci majors are going to come in and work on the same projects because those kind of things involve a lot of different disciplines. So that's one of the cool things about being in the College of Engineering. Just at Temple in general, you're exposed to a lot of different things that you wouldn't be exposed to otherwise. So you're able to get some of those other skill sets that you wouldn't get straight from your classes.
Great, thanks, Prem. And we have another question from Simon, and this is a good question for everybody, I guess, is with the pandemic going on and moving to online coursework, do you think that the rate at which students are gaining knowledge will be the same as physically being on campus? So I guess I'll turn this one to our faculty first. How do you see kind of the delivery of coursework in the midst of online learning?
Ladies first, I can chip in afterwards.
Okay. So to be honest, I think ours has gone, the classes that I am leading have gone over pretty well in terms of transitioning between in-person to virtual learning. And that's because our class tends to be more discussion based, and we don't have as many of the hands-on components. So for us, the transition was really seamless. And I think there's a lot of perks to having the online component. I think it's kind of taken a little bit of stress off of students. They don't have to run back and forth between classes, and so then by the time you sit and you're ready to learn, it's been a little bit easier, I think, to kind of like just transition in. So I mean, yeah, I guess I can speak mostly to the classes that don't have the component that requires in-person. We do have our labs that we run. So the labs that both Dr. Lelkish and I run are operating in person at reduced capacity. So we have a lot of rules in place to maintain everybody's safety. And we follow the pillars of health that Temple outlined for us and have additional criteria for our department specifically. And so that's been going really well. And that's been a nice balance because it still allows students to get in and do the hands-on research. They're not losing out on any opportunities there. So that's really important. And if you have independent study to do research, you're also allowed in for that as well. So yeah, I haven't noticed any downsides yet. But again, my class, like I said, is not as hands-on. So,
so in general, I think this is a two-way street to look at. So it's the instructors getting used to this way of education and the students getting used. And I can tell you from my personal experience, when we had to switch from in-person to online with 24 hours or something like this notice in the spring, it was a bit hard. And there were some bad feelings. Students felt sort of left out and left on their own to study. But we have had the summer where we were trained. The students got used to the online chats and online activities. And when this, speaking from my own classes, when we came back in the fall, this has significantly improved, both because I personally learned much more in how to run a class online. And as Dr. Bella said, we put in a lot of discussions, and the students are much more involved than they used to be. So this is definitely a plus. And also the students have learned how to deal with the online experience. And I think they are willing to accept this, and they are willing to put in different ways of working and studying, but they are successful. The grades are definitely not worse than they were before in terms of the experience. In terms of labs, yes, we have labs that have to go hands-on because these are the labs that involve live cells. So there's nothing that you can do online with a live cell. But on the other hand, we have successfully transitioned some of our main educational labs, such as the introduction to bioengineering, such as electrical circuits, such as biomechanics labs into online courses. Amongst others, we send the students kits, and then they build their devices and their circuits by themselves and actually have fun with it at home. And no one has burned down a house yet. But, so.
Great, thank you.
I think this is quite successful.
Good. So the webinar will conclude at 6:30. So we have time for, I'm not sure if anybody has any last minute questions or last minute comments, but I want to thank our faculty and our students for being here tonight. I think this was a really great site. It's always very helpful for me. I love hearing about everyone's experiences and learning more about the college. Even though I've been here for almost 3 years, I feel like I learn something new every time I speak with these people, which is really exciting. I know it's no substitute for being in person, but we do offer some virtual tours on our website as well as on Temple's website as well. But until we can meet in person, please don't hesitate to get in touch with us, and we hope that we'll see you all in the fall. And please reach out to us if you have any questions in the future. And best of luck to everyone, and hopefully we will get to see you in person sometime soon.
Okay.
Thank you.
Thank you everyone for participating, and take care.